in this next part of chapter 1, we are looking at a short little section on collection of gas. So previously in my earlier video, we have seen that to collect gaseous volume or measure gaseous volume, a gas syringe is typically being used. But actually, besides using a gas syringe, which is able to be used on all types of gases, there are actually 3 other methods in terms of gas collection. So let's take a look at which are the methods and why do we choose them, when do we choose them, okay, in terms of the preferred choice of collection. Okay, so we should be on page 5 of the notes. Right, the gas collection method will be chosen based on 2 criteria. Okay, it depends on whether the gas that you are collecting, whether the gas that you're collecting is the gas soluble in water or not. Okay, and we also will need to check whether the gas that you're collecting, is it of a high density or is it of a low density with reference to air. Okay, so this is the point where I have to help you out a little, okay, because you might not have all the prior knowledge about air. Now, air is made up of 78% nitrogen, 21% oxygen, and 1% of this gas called argon. And due to this combination, right, air has what we call a relative molecular mass of 28.96. Okay, do not worry too much about this number because I will be doing an elaboration later on. Okay, so this is, you can say, how heavy air is. So any number or any MR value or any MR value stands for relative molecular mass. Any MR value that is higher than 28.96, we can say that the gas is actually denser compared to air. Values lower than this number will be considered less dense than air or lighter than air. Okay, so first up, our first method of collection of gases is called water displacement method. Okay, so water displacement method, basically, you will take what we call a delivery tube and you will bubble the gas through water. Okay, and because the gas is insoluble in water, okay, the gas cannot dissolve in water at all, so it will actually start to occupy a space in this jar that was originally filled with water, and it will slowly push the water down. Okay, so you'll be able to collect the gas over here. So if you allow all the water to be eventually pushed out from the gas jar, then the gas jar will be filled with just the gas. So it is suitable for insoluble gases or only very slightly soluble gases. Okay, so they dissolve very little, but most of it will remain insoluble, so you can still use this method to collect. Okay, just a word of caution, if the gas is slightly soluble in water, then you will not expect the total volume of gas collected, right, to be equal to the volume of gas that enters the gas jar. Okay, why is that so? It's because for example, let's say you are expecting the 60 cm cube of gas being collected, but because part of the gas is soluble, so maybe 5 cm cube of the gas dissolve in water, all right, then in the end, you will only collect 55 cm cube of the gas. Okay, yeah, so if question actually asks you, oh, why do you think the volume collected is lower than expected? This is very likely the reason. The gas could be slightly soluble. So such examples of gases which could be slightly soluble in water would be carbon dioxide and oxygen. Hydrogen is insoluble. Right, some of you might ask, do we need to memorize which gas is soluble, which gas is insoluble? No, you don't have to memorize at this stage. Okay, subsequently, as you have gained more experience, then you will learn about it. Okay, so let's move on. So that is for water displacement. The reason why you choose it is due to this fact. Okay, then the second method, right, of collecting a gas is called upward delivery method. Okay, so you will realize there is actually a typo in your paper, so you need to change the word downward to upward. Okay, so it will look something like this in your notes. Okay, change the two words over here. Okay, so back to my slides. So this is called an upward delivery method, where you allow the gas, right, to be collected, okay, in an upward direction. Okay, what kind of gases do we use this method to collect? Okay, very simple. This collection method, right, is very suitable for gases which are less dense than air. So the gas will tend to float, and therefore they will hover around this region. Okay, so that's what upward delivery is all about. Such a gas is actually ammonia. Likewise, do not worry about it. For now, we will actually tell you how heavy the gas is, so you need not be worried about it. Okay, solubility is not important in this case. So density is the determining factor why we use upward delivery. Downward delivery will be the opposite. Okay, downward delivery, you are delivering the gas downwards. Okay, so you can see the direction of the delivery tube is downwards. So it is suitable for gases that are denser than air, so they tend to sink. Okay, so they will stay at the bottom of the flask. Right, so these are some examples of the heavier gases. Likewise, you do not need to memorize. Okay, and of course the last method, which is in your notes, would be gas change. Gas change works for all gases. The only maybe I would say restriction would be gas change has a limited capacity. So if the volume of gas that you're trying to collect is quite large, then the gas change might not be able to serve this purpose. Okay, so you can end off by doing page 6 of your notes. There are 2 questions there, and we will discuss in class.